Hi guys, welcome to the repair shop. Just kidding. I got a few components. So that's the first part of the shipment which I made last time, right away after my last inverter broke. And so on the table today is the SUN2000, which died on a I would say switching, AC side switching, which was kind of harmful because it was a very short interruption. An interruption we have here in Thailand many times, but sometimes these devices, you know, if you got them on the wrong foot, may be damaged that way. So in this case, the only thing I found was the two MOSFETs which have completely shortened, and when that happens, usually gate resistors and the gate driver will also die. So I have got MOSFETs, I have the gate resistors, and I have the gate driver. And this should already be it. But to do this job, I have to disassemble all this middle part here. So there's a heat sink in the middle of this inverter, and to remove that heat sink I have to remove the temperature sensor here, the small fan at the beginning, and then I have to unscrew all these holders for the transistors, and then I can just remove the screws on the down and take out the heatsink. So without any further delay, let's do the job. Okay, let's start and remove the temperature sensor. Then this small fan here. Okay, now unscrew these transistors. And the nice thing about this design is here actually that they always put these components here on the side, the way that you can go in between with a screwdriver and unscrew those holders. But the only thing actually is you need a very thin shaft of the screwdriver. This is the newest of the three inverters which have failed, and actually you can see revisions on the boards, but also the components, the parts are always different. You will never find the same part numbers on each of these inverters. And that's what makes it kind of difficult when you source for the components. You always have to read data sheets because you will never get the same one what is inside the inverter. So now two more are left. Okay, that was the top side. Now let's go to the back side of the board and unscrew the heatsink from the down. Okay, that should have been it. And you see the heatsink comes just out. Here's the silicone tape. That's a shame. It's actually brand new inverter and already failed. So let me show you the parts which need to be removed. Here we are. you know, the two transistors from the last video I have already removed. They will come here into this place. Then we have 10K resistor, gate resistor, that's the pull down resistor on each side, and the 20 ohms resistor on each side, that's the gate resistor. And this here is the gate driver. This one actually still looks quite nice. It did not disintegrate. On the other two inverters it blew off its cap here, but it still looks good. But nevertheless I'm going to replace them, because usually they will always have the damage as well. Otherwise this inverter looks quite good, and there should be nothing else wrong with it. But before we start soldering, let's just check resistances quickly. So the input, AC input L and N, you see now we have around 90 kilo ohms. The gate resistor 20 ohms, this one seems to be quite good still. The other one 20 ohms also. 9 kilo ohms the pull down, and 9 kilo ohms the pull down. As the resistors actually measured quite good, and everything looks quite neat on this board, I will only replace the gate driver. Okay, here's the old one. It's a little bit tricky place here where this gate driver is positioned. It should still be manageable when you remove the heatsink. I will do it with the soldering iron. Put solder on one pad and try to place it. The gate driver is a FEN 3224T, a chip. So the chip is in place. Yeah, that was the driver. Yeah, and the joints look good. Okay, so yeah, a little bit tricky. If you cannot reach this chip, you can still also remove the transistor right next to it, and maybe a capacitor. But yeah, the capacitor got a little bit sunburn from my soldering iron, but yeah, should not be damaged or anything. Okay, the next is let's place the MOSFETs. The MOSFETs are 24 and 60 C3. That's MOSFET from Infineon. So as I said, you will never get the same component what you pull out of the board, but that does not really matter. You just need to check that the parameters are similar, at least as close as possible. I will actually now already mount the heatsink again, so we can put the transistor in the perfect place before we solder them. So the magnification glass is of course the poor man's microscope. That one is an 8 times magnification, so it's quite nice. Heatsink is in place. I will use a few of these clamps just to hold everything together before I turn the board over. This is one of the nice features of Chinese products. They're usually repairable. Okay, I'm turning the board over. And fixing the heatsink from the down. Yeah, it's fiddling around in any way. It's a real advantage if you have small fingers. Because I have this one in my hand, let's put this one. So the fan is back on. Okay, that was it initially. I will now solder the transistors. In the last video I also said that we have to change the shunt resistors, but on this one those did not have any damage. The shunt resistors were damaged on the inverter, which had the lightning. Right, so the transistors are in. Just clip the legs away a little bit. Looks good to me. Yeah, in theory this should be now a working inverter. We are going to test it, of course. I'm not just plugging it into the AC. I have here a very sensitive breaker and an RCD. This is connected. So what has to happen, for me it's not important what is shown now at the display at the moment. The most important is that the inverter is powering up and it is showing anything, right? If this is working out of the box, then we will put all the other screws and put it into the box, of course. Okay, let's hope for the best, right? Shall I go a little bit to the back? Maybe that's a good idea. And power on. Oh, the fans just spun a little bit, and oh, ho, ho, ho. Look at this. We do have a display. The inverter is writing a starting voltage to low. This is the DC and no other fault. So this inverter is Now I have to put all those other clamps on the transistors. Okay, so the board everything is mounted. We can now close. The inverter. And that's it, that was the last screw. We're going to test this now also by using DC. I will pick up my power supply and then see what it says, if there's anything other, another fault written in the display, or if this is now good. Final test, shall we? AC. The inverter have powered up. As before, we have the message starting voltage too low. I have set my power supply to 55 volts, so the maximum, and like 1 amp, turn it on. Increase the current, and now we have 55 volts. And yeah, the inverter is showing. You might see it. The inverter is showing now no fault, 235 volts, 55 volts on the DC side. 0 watts, of course. We are not connected via a CT, so it does not know what to do with the power anyways. But yeah, great job. The inverter is working. Oh well, guys, why can't we just fix stuff? You know, same other YouTubers do. They fix stuff and it works, period. But in my case, there's always a problem, right? Okay, I have the inverter here again. It's open and it is running now, and it is also pushing power into the grid. So what I'm using is my power supply. It can provide around 300 watts, and yeah, due to the MPPT tracking and maximum current which it will take, probably like this. Okay, a little bit more is in here. Yeah, I can get out 200 watts. But the inverter is working fine. So the only difference now, other to when it was hanging in the power wall, is I have deactivated the CT and I'm running it on a quite low power level, right? So when this is connected to a battery, then of course the battery will push as much DC in as the inverter is requiring, and this one is set to 1500 watts. But okay, 200 watts, 220, absolutely no problem. So yeah, what are we going to do now? I was watching some YouTube videos from the channel Der Kanal. It's a German YouTube channel. It has also quite a lot of SUN inverter repair videos. And there were two cases which were kind of similar like that, so power ramping up and then aborting. But it's none of these issues which have solved the problem there can help me out here. So in one case there was a loose shunt transistor on the DC side. I have reflowed them, there's no issue with them. And the other is a capacitor on the control board. I have now replaced that capacitor. It measured quite normal, and this is now with the new capacitor. So I unfortunately did not test the inverter with the old original capacitor inside. So is it fixed now? Probably not. So if I'm going to install this again, put this in the box, it will not work. I have measured a little discrepancy on another shunt transistor on the AC side, and that one I'm waiting still for. It is in the order, and I want to replace it because it is 20% of its nominal value, so there could be actually an issue with the current metering, because this now ramping up, aborting, this is telling me that this is now a control problem, right? Because the controller is seeing somewhere in the inverter an abnormal behavior and is aborting the ramp up. The controller seems to work. The only thing what I could try is use the other controller from the other SUN2000. The inverter is back inside the power wall, and yeah, you see it works. This is now with the C1 capacitor changed, a different control board. So it makes no difference. The problem is just that the power output is limited. I have set the inverter to a maximum output now of 520 watts. It is following the CT, but I'm not getting my 2000 watts, so 1500 is usually what I set here. 500 watts, and that's it. When I had 600, it worked for some time, but then it still have shut down. Yeah, so I can't do much more at the moment. What I will do is I am still waiting for some parts for the other SUN2000, that is including shunt resistors, and I think I will replace the shunt resistors which are inside this inverter. Maybe there's a problem with current measurement, and when the inverter is sensing some difference between DC current in, AC current out, and something like this, that then it aborts the operation. So yeah, that's all what I can do. I will let the video finish here, because I'm always curious about your opinion, your comments on the down. So yeah, not much more to see here. We have a quasi working inverter. 500 watts is still a little bit. I have 3 inverters here in the power wall, so during a night this can also still discharge the battery by almost 1/3 if it's always pulling 500 watts. Okay, so please like the video if you enjoyed it. I hope you found it interesting. Comment on the down and subscribe to the channel. I see you next time.